Hey guys, this video is going to cover notes 8.2, Pythagorean theorem and its converse. So to start off, we just want to review Pythagorean theorem. Pythagorean theorem states that if a triangle is right, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Or in other words, given the triangle here off to the right, this will hopefully make a little bit more sense. It's understood that if I have a right triangle where my legs are A and B, and my hypotenuse is C. In this scenario, it's understood that for Pythagorean theorem, we know a squared plus b squared equals c squared, where it's extremely important to note that your hypotenuse is going to be your longest side always. Okay, this is always your longest side of your right triangle. And this is also noted that your hypotenuse is across the 90-degree angle. Right, so we see here that my hypotenuse is across the 90, and it should also be understood that C, the hypotenuse, is the longest side of any given right triangle. I'm going to say that again because that's extremely important, especially for the examples that we look at later in the notes. Your hypotenuse is going to have to be C, and that represents the longest side of the right triangle. So we also want to make sure that we are having the conversation going over Pythagorean triples. Pythagorean triples are defined as a set of three non-zero whole numbers, a, b, and c, that satisfies a squared plus b squared equals c squared, right? So for example, down below, we can see here that, well, this is a, this is b, this is c, right? Where we understood that, remember, c is the longest side. And so if I were to do Pythagorean theorem here, what we have here is, well, a squared plus b squared equals c squared would be 3 squared plus 4 squared is equal to 5 squared. Where we get, well, this is 9 plus 16 is equal to 5 squared is 25. 9 plus 16, when I add those together, we get 25. So 25 is equal to 25. This is known as a Pythagorean triple, right? Where all three of those sides in the right triangle are going to be whole numbers, right? So that happens to be one of our Pythagorean triples. We'll look at another one here, right? Just for context, here's our Pythagorean theorem, a squared plus b squared equals c squared. Here's my a, here's my b, here's my c. I know that 13 is c because I know for a fact it's across the 90 and it's the longest side. So if I do Pythagorean theorem here for the second example, we have 5 squared plus 12 squared is equal to 13 squared, right? That's my a squared, b squared is equal to c squared. 5 squared is 25. 12 squared is 144. And we're checking, is that equal to 13 squared, 169? Well, if I add the left-hand side together, 25 plus 144 is 169. It's equal to 169. Okay. One thing that I purposely didn't read here off to the top right that I do want you to pay attention to now that is important is we need to really understand that multiples of Pythagorean triples are going to be Pythagorean triples themselves, right? So if I take a Pythagorean triple and multiply all of those sides by the same amount, then that new triangle formed would also be a Pythagorean triple. So consider the first triangle we looked at. What is the relationship from the first triangle to the second one? What did I do to that side length of 3? What we did there was we multiplied it by 5. What did I do to this bottom side of 4? Yeah, 4 times 5 gives us 20. Right? Same thing with the hypotenuse. 5 times 5 gives us 25. So what we've done effectively is for that first Pythagorean triple, the 3, 4, 5, which is probably one of the most famous, we've multiplied every side length by 5. So this triangle off to the right represents a multiple of the Pythagorean triple. And if what we're saying is true, then this will end up being a triple itself. So, well, let's check. Here's my A, here's my B, here's my C. If I were to do a squared plus b squared equals c squared, we're looking at 15 squared plus 20 squared is equal to 25 squared. 15 squared is 225. 20 squared is 400. And 25 squared is 625. And if I add these up, yeah, 225 plus 400 gives me 625. So this is a Pythagorean triple. So now we understand a little bit more about Pythagorean triples. Let's go ahead and start looking at some examples throughout the notes of questions that you might actually see. So in example 1, it says, you are standing beside the Colorado River, 500 feet from the Hoover Dam. Using an electronic device, you find the distance to the top of the dam to be 985 feet. Find the height of the dam. So for these types of problems, especially when it's a word problem, excuse me, always going to be a good idea to draw a picture. So says that we're standing beside the Colorado River, 500 feet from the Hoover Dam. So I'm seeing here 500 feet from the Hoover Dam. So here's my Hoover Dam, and we are standing 500 feet away from it. And it says, using an electronic device, you find the distance to the top of the dam to be 985 feet. So the distance from where we're standing to the top of the dam is understood to be 985 feet. And lastly, it's asking us find the height of the dam. So our height, which is our vertical distance here, would be our x, our unknown. And so we're understanding here that this dam is going to be standing upright, so we are going to have a 90-degree angle that's formed here. So now that we have a better understanding of this problem and we have a picture as reference, now we can go ahead and go through Pythagorean theorem and solve for x, the height of this dam. And the question is asking us to round to the nearest 3 decimal places. So I'm going to start by working off to the left here. We have a squared plus b squared is equal to c squared, right? And so, again, like we mentioned earlier, c represents your longest side, which is across the 90-degree angle. So there's our c. That means that 500 could be a, and our x could be b. Really, a and b can be interchanged, right? It doesn't really matter which one you pick for a, which one you pick for b, but what does matter is that you pick the correct value for c, which is the hypotenuse or the longest side of the triangle. So now that we got everything labeled, plugging everything in, we're looking at 500 squared plus, well, b is x, so x squared is equal to c squared 985 squared. All right, so for this one, probably going to be a good idea to grab a calculator here. 500 squared is going to be 2,500. Sorry, not 2,500, 250,000. And then plus x squared is equal to 985 squared would be 970,225. From here, what we're looking for is solving for x, that height of the dam. So I need to get the x by itself. So I'm going to subtract the 250,000 on both sides. Doing so, we get 720,225, right? So we got x squared is equal to, like we just said, 720,225, right? And if I want to solve for x, the way that we cancel out a squared is, remember that we cancel that out by taking the square root. Let me draw that a little nicer here. So if I square root both sides, what happens now is that the square root cancels out the squared, and we're left with, I'm going to just put the squiggly equal sign because this is an approximation here. The square root of 720,225 gives us a really long decimal, which if we were to round it to the nearest 3 decimal places would be 848.661. So to answer the question, the height of the dam is going to be approximately 848.661, and the units we're looking at here is feet, right? So not a pretty looking answer. We do get a pretty long decimal here, but Pythagorean theorem, this shouldn't be anything brand new. This is something that we've definitely looked at in middle school before. Next, let's look at a slightly more challenging problem. Example 2. It says Ashley has a right triangular garden in her backyard. The longest side of the garden measures 17 yards. One of the sides is 10 yards long. Find the perimeter of Ashley's garden in exact and simplified form. So if I take a look here, some important pieces of information that we're told here is that the longest side of the garden measures 17 yards. And it tells us that we're looking at a right triangular garden. So right triangular garden would imply that we're looking at a right triangle. And if it tells us the longest side measures 17 yards, then that represents our hypotenuse. And then it says one of the other sides is 10 yards long. So I'm just going to call this one 10. Now it says find the perimeter of Ashley's garden in exact and simplified form. For me to find the perimeter, I need to add up all the sides. But I can't do that because I don't know this missing side here, the vertical one, which I'm going to call x. But we can use Pythagorean theorem to find that missing side. Pythagorean theorem can always be used as long as you know two sides of a right triangle. So if I'm looking at Pythagorean theorem, here's my formula. And this takes like 2 seconds. It's never a bad idea to just label your right triangle. This is my C, this is my A, this is my B. So plugging these numbers in, we have 10 squared plus x squared is equal to 17 squared. Well, 10 squared is 100 plus x squared is equal to 17 squared, which is 289. And then from here, we want to solve for x squared, so I need to get rid of the 100. Doing so, we get x squared is equal to 189. Excuse me. And so to solve for x, I need to cancel out the squared, so I'm going to square root both sides. And so what we're looking at now is x is equal to the square root of 189, right? But I need to check, can I simplify this? Well, 189 is not an even number, so I can't divide it by 2, but what I want to check for is, can I potentially divide it by 3? Well, let's check. 189 divided by 3, well, yeah, that is divisible by 3. I can divide it by 3 and get 63. So 3 is prime. 63 breaks down into 9 times 7. 9 is 3 and 3. And 7 is prime. So rewriting this as a product of prime numbers becomes 3 times 3 times 3 times 7, which we can see here I have a pair of 3's. So that means 1 3 comes out, and we're left with 1 3 on the outside. Underneath the square root, all we have remaining is 3 times 7, which is 21. So the height that we were missing there, we can now understand that that is 3 square root of 21. Now, the question asked us to find the perimeter. The perimeter would be found by adding up all the sides. So my side length, we have 17, we have 10, and then we have 3 root 21. Right? Well, we looked at adding and subtracting radicals in our radical review. The only way I can add something to a square root is if it has the same number under the square root. So I can't combine the 3 root 21 with anything, but I can combine the 17 and 10. So my perimeter would be 27 plus 3 square root of 21. And the units we're looking at here is yards. All right, we'll do part 2 of this video here in just a little bit. My voice is actually killing me right now, so hang tight for part 2. All right, this is going to be part 2 of the video. I chugged 2 bottles of water, so I'm hoping that I make it to the end of this video. But let's go ahead and start off by recalling what the Pythagorean theorem says. The Pythagorean theorem says that if a triangle is right, then a squared plus b squared is equal to c squared. So what I want you guys to consider is, what would the converse of this statement say? Just to kind of recap from what we learned earlier this year, the part after the word if represents p, the part after the word then represents q. The converse is written by swapping the order, by writing this as if q then p. So the converse of this statement would actually read, if a squared plus b squared is equal to c squared, then the triangle is right. And this actually happens to have a really formal name to it. This is known as the converse of the Pythagorean theorem, and it is extremely important. The converse of the Pythagorean theorem basically says, if a squared plus b squared is equal to c squared, then we have a right triangle. And so what I want us to take a look at is, let's see what happens if we were to try to use the Pythagorean theorem on some triangles that are not right triangles. So to start off, why don't we look at these acute triangles here, right? If I'm using Pythagorean theorem here, remember that this Pythagorean theorem is a squared plus b squared is equal to c squared, where c is the longest side. So if I take a look at the first triangle, C, my longest side is going to have to be 14, making A 9 and B 11. So if I do Pythagorean theorem, we're doing 9 squared plus 11 squared is checking to see, is that equal to 14 squared? Well, 81 plus 121 is equal to 14 squared is 196. 81 plus 121 is 202. And we're seeing here very clearly that these are not equal. Right? I'm going to write this down here below for context so that we understood where these numbers came from. The 202 came from a squared plus b squared. The 196 came from the c squared. And so let's take a look at the example off to the right. Now, again, we're looking at C representing the longest side. And we know that between 9 and 11, 11 is obviously bigger. What we may not be entirely sure of is which side is bigger, 11 or square root of 115. If you're not sure, one option that I would recommend is type in square root of 115 into the calculator. If you type that in, you'll see that it's approximately 10.7, which means that out of all these three sides, 11 happens to be the largest. That must be our C, meaning that we can call 9a root 115b. So Pythagorean theorem here, if we're looking at 9 squared plus the square root of 115 squared, is that equal to 11 squared? Well, 9 squared is 81. The square root and the squared cancel out, so that leaves us with, well, root 115 squared is just 115. 11 squared is 121. If I add these two values on the left, 81 plus 115 gives us 196. And what we're seeing here is that these are clearly not equal, right? And just like we did on the last one, we're going to write underneath here, the 196 came from a squared plus b squared. The 121 came from c squared. So what I want us to look at now is, let's take a look at c squared. What do you notice about c squared? So looking at the first example that we did here for the acute triangle, what are we noticing about c squared? Hopefully you guys are realizing here that c squared is smaller, or it's less than what we got for a squared plus b squared. If I look over here on the example to the right, let's look at c squared again, 121. We can notice pretty much the same thing here. 121 is also less than 196. So the conclusion we can make here is, well, I'm noticing that c squared is less than a squared plus b squared, right? If the triangle is acute, because we haven't really looked at other types of triangles. For these two happen to be acute. So we looked at acute triangles, and we're saying here that, well, I'm noticing that c squared is less than a squared plus b squared. Well, if you were to take a guess, obtuse, well, if acute is having c squared less than, then obtuse could potentially mean that it's greater than. And we'll take a look and hopefully come to that realization by looking at these examples below. For these obtuse triangles, let's use Pythagorean theorem and see what happens, right? Remember, c is the longest side, so in this particular instance, we're looking at 7 being c. Here's our a, here's our b. So we have a squared plus b squared is equal to c squared, where we're looking at 2 squared plus 6 squared equal to 7 squared. Well, 2 squared is 4, 6 squared is 36, 7 squared is 49. 4 plus 36 is 40. That's clearly not equal to 49, right? Which should make sense, right? Because we said earlier the converse of the Pythagorean theorem said that, well, if they're equal, then it must be a right triangle. And I'm telling you right here that this happens to be obtuse. So yeah, these should not be equal. But underneath here, I'm going to write that the 40 came from a squared plus b squared. The 49 came from c squared. Now, let's take a look at the next one, okay? The next one, 12 represents your longest side, so let's mark that as C. A will be 8, B will be 6. So we're looking at 8 squared plus 6 squared is equal to 12 squared. This gives us 64 plus 36 is equal to 144. Well, 64 plus 36 is 100, and we see here very clearly that that does not equal 144. And for context, the a squared plus b squared is where we got the 100. The 144 came from the c squared. Right? And so I'm going to ask you the same question again. What do you notice about c squared? Okay, what I'm noticing about c squared here in this situation is going to be the fact that in both of these examples for the obtuse triangles, c squared happens to be bigger or greater than the a squared plus b squared. Similarly over here, the 144 is bigger than 100. The c squared ends up being greater. So what do I notice about c squared? I'm noticing that c squared is greater than a squared plus b squared if the triangle is obtuse. And so I could have just told you that, but I feel like you guys kind of seeing that and more or less figuring that out on your own is a lot more powerful because now you know what to look for, right? And so bringing this full circle here, now we can understand when to use this. We can use the converse of the Pythagorean theorem to determine if a triangle is a right triangle, but we can also use it to determine whether or not to figure out if the triangle is acute or obtuse, right? And so we kind of wrote this here in green up above. Here's just us reiterating it formally in just this table so that you have this as reference. In a right triangle, you're going to notice that a squared plus b squared is equal to c squared, looking at this little equation, right? What you're looking for here in parentheses, what you should be asking yourself or looking for is that if it's a right triangle, c squared is equal to a squared plus b squared. Next, if it's an acute triangle, you're going to end up with the following, that a squared plus b squared is greater than c squared. But this, in my opinion, makes more sense to look at it in the context from c squared's point of view. In this case, if it's an acute triangle, c squared is going to be less than a squared plus b squared. And then lastly, in an obtuse triangle, you'll end up with a squared plus b squared is less than c squared. But again, this will make more sense looking at it in the context of c squared. So in this situation for obtuse triangles, c squared is greater than a squared plus b squared, right? And so let's look at some examples of what will some of these questions actually end up looking like. So it says, example 3, identify the following as acute, right, or obtuse, right? So here's more or less the criteria that we're looking for. A squared plus b squared, we're comparing that to c squared. I'm going to put a box right here because we don't know for these problems, is it equal, is it less than, is it greater than? That's what we're testing for, right? So what I'm testing for here for all of these is what I'm writing here in green. Is it equal, less than, or greater than to c squared? Okay, so labeling this and getting this set up to identify whether these are acute, right, or obtuse, I want to start with identifying what my c value is. C is the longest side. So in this case, 17 is c. We can call 8a, b can be 14. So setting this up for Pythagorean theorem, I'm looking at 8 squared plus 14 squared. I don't know yet in comparison to c squared, which is 17 squared. Well, 8 squared is 64, 14 squared is 196, and 17 squared is 289. Well, if we add these up, 64 plus 196 happens to be 260. And now we can answer this, right? Comparing 260 and 289, we can see here that the 289 is greater, right? So for context, like we did earlier, the 260 came from the a squared plus b squared. And the 289 came from the c squared. And we're seeing here that if I look at this from the perspective of c squared, I see here that c squared is bigger or greater than, right? Looking back above, when it's greater than, we say that the triangle is obtuse. So this is a obtuse triangle. And so let's try the next one. If I look at the next one, okay, I'm looking here at this triangle. I got 3 side lengths here. The square root of 113, I'm not entirely sure what that number is, so I would type that into the calculator. And we'd see that the square root of 113 is approximately 10.6, right? So that's an indicator that root 113 is our largest side. So our largest side here, we're going to label it as C. That means that 7 is A, 8 is B. What I'm checking for essentially is this. So plugging these values in, we're looking at 7 squared plus 8 squared and comparing that to the square root of 113 squared. 7 squared is 49, 8 squared is 64. The square root of 113, remember that the squared cancels out the square root, so we're left with just 113, right? If I add these up, 49 plus 64 actually gives us 113, right? So comparing these two values here, what I'm seeing here is that it's equal. I'll write that a little nicer here. We get that it's equal, right? So I guess I might as well just fill this in here at the top because I wrote the criteria at the top that we're checking, right? The a squared plus b squared in this situation happens to be equal. So that means that we are looking at a right triangle, right? If they're equal, okay, like we saw above, if they're equal, then it's a right triangle. And then lastly, let's take a look at the one on the very far right. We see here that, again, we have another square root, so probably a good idea here to check to see which side is my longest. Don't just assume visually, well, it looks like the hypotenuse would be 4 root 95. No, do not assume. Actually look at the numbers and verify which side is the largest, right? So if we were to plug this into the calculator, the square root of 95 times 4 would give us approximately 38.987. So approximately 38.987, which tells us that the 4 root 95 is our largest side. So we'll call that C. This will be my C. Let's make A 15, B 36. The criteria we're checking for is A squared plus B squared, comparing that to C squared. Is it equal? Is it less than? Is it greater than? So plugging these values in, what we're looking at here is 15 squared plus 36 squared, and comparing that to whatever 4 times the square root of 95 squared is. So looking at this here, 15 squared is 225, 36 squared is 1296, and here's where you want to be careful, okay? When you're squaring something in parentheses like this, you need to understand that you're squaring everything inside. So I'm squaring the 4, which would be 16, and I'm squaring the 95, which, remember we said that the squared basically cancels out the square root. So we're left with just 95. All right, so let's add here and then multiply on the right to compare. So on the left, we're adding 225 plus 1296. That gives us 1,521. And on the right, 16 times 95, that gives us 1520, right? So between these two numbers, we're seeing here very clearly that the 1521 is bigger, so it's greater than there. And I'm going to draw my greater than symbol here. But after you kind of fill this out, again, you're looking at this in the context of C squared. C squared is on the right, the 1520. We're seeing that C squared is less than the A squared plus B squared. If I see here that the C squared is less than the A squared plus B squared, then we say that the triangle is acute. So this is a acute triangle. All right, and so that in essence is going to be what most of our examples look like whenever we're asked to identify. I can give you a picture or I can just list out the side lengths. But again, verify what side is the longest to make that your C value when doing these types of problems. We'll finish up here by looking at a similar question here just on a coordinate plane, right? I went ahead and took the liberty of actually graphing these out for you. It says determine whether triangle ABC is a right, obtuse, or acute triangle given the following coordinates. And they give you the coordinates of A, B, and C. Right? I just did a rough sketch of a graph. It doesn't have to be perfect, but if I want to see if this is right, obtuse, or acute, I need to find the length of each side, right? So for us to find the length of each side, what we basically did here is use the distance formula from A to C in red. That gave me the side highlighted in red as root 45. Same idea here for the side in blue, AB. Use the distance formula from A to B to find out the length of that side. And then in green, use the distance formula from C to B to find the length of that side. So what we're seeing here essentially is the distance formula already kind of worked out for us. Now we're pretty much working in the same kind of situation that we were in earlier, right? Where they gave us a triangle and we have all sides that we're asked to find, right? So looking at our three sides here, root 45, root 80, root 125, it's going to be very clear here that this is our biggest side. We're going to call that C. We can call the root 45A, the root 80B. So we're checking here, A squared plus B squared. How does that compare to our C squared? So plugging this in here, we're looking at root 45. That's our A. We're going to square that. And then we're going to add our B in blue, root 80. We're squaring that. And we're checking to see how does that compare to our C squared in green, which is root 125 squared. So cool thing about this one actually, and you'll notice that when I did the distance formula, I could have simplified root 45, root 80, root 125. I could have simplified all of these, but I chose not to because at the end of the day, I knew I was going to do Pythagorean theorem and square these. And I know that when I square them, that the square root will just cancel out with the squared for literally all of these, which leaves us with us basically just adding here. And what we're adding here is 45 plus 80, how does that compare to 125? Well, 45 plus 80 is 125. So we can see here that how does this compare? They're equal. So to answer the question, if a squared plus b squared is equal to c squared, then this happens to be a right triangle. All right, so if you need to pause the video to get all this set of notes down, I know I try to make this go a little smoother by finding the distance formula for you guys, but to summarize these types of problems that are on a graph, a coordinate grid, if I don't provide you with the graph, just sketch one out and find the distance of, point A to point B, B to C, C to A to find out the lengths of all three sides. Once you know all three side lengths, then do Pythagorean theorem to test to see if it's acute, right, or obtuse. But that'll be the end of the video. Please make sure that you guys are working on the assignment. It should be next in the packet.